puts them in inclined planes. All right. This thing is called Atwood machine, and what they're using is they're using a pulley to direct the force applied so that you can lift heavier objects with a little bit of ease, you know. Especially if you want to lift a heavy object, you have a counterweight on the other side, right? And then if you just pull down with a little bit of force, you would actually lift heavier objects higher position. Okay? First thing that is very, very important is that you really need to make the direction of motion to be positive, okay? And that is very, very important. And to do that, we have to know which way it's going to go. Okay? Another assumption you have to make is the cord itself is massless. Okay? And frictionless pulley. So there's no friction in this pulley, as well as massless pulley. Later on, when we actually do rotational dynamics, we may have a pulley that has mass. Then it would actually resist from turning, and it would create different tensions. As long as this pulley does not have friction and the pulley itself is massless, okay, you don't have to worry about this tension and this tension being different. They're the same tension. Okay. And we also are going to use massless rope that doesn't stretch or shrink. Okay? So those assumptions must be made. Now, let's take a look at this setup. This is called Atwood machine. And without even knowing physics, I have 10 kilogram mass hanging here and 2 kilogram mass here. Which way will this go? Huh?
10 will go down.
Yeah, 10 will go down and 2 will go up. So this is the direction of motion. Always indicate on that problem. Okay? That means my 2 kilogram mass, this direction is the positive direction, and this direction is the negative direction. And for the 10 kilogram mass, this down is the positive direction and up is the negative direction. Okay? It's very important to establish that. Now, if I were to do a free body diagram just on this mass 1, how many forces are acting on this mass 1? 2, right? The obvious force is Fg, right? Of mass 1, right? And we have tension, right? Tension. This tension is exact same tension as this tension right here. So this tension and this tension are same tensions. For mass 2, we also have 2 forces. One is Fg2 and same tension. Okay? So, let's take a look at, starting with this one, okay? We say sum of all force for mass 1 is equal to M1A. And sum of all force 1 for mass 1 is equal to, it looks like I only have 2 forces, which is tension plus Fg1. Set them equal to each other. M1A is equal to tension plus Fg1. Right? Now, give directions. Okay? So M1A is equal to tension, positive or negative? Good. FG1? Very good. All right. Just brought your A game today. So, if I solve for tension here, my tension is equal to simply M1A plus M1G. So this is my tension. Now I don't know acceleration of the whole system. If I know the acceleration, my tension can be solved pretty easily, right? Well, let's take a look at my mass 2. Okay? So sum of all forces for my mass 2 is equal to M2A. This acceleration has to be the same acceleration as that because they're attached. Okay? Therefore, sum of all force 2 is equal to, again, I have two forces. I'll get Fg2 plus tension. So when I set them equal to each other, M2A is equal to Fg2 plus tension. Now, give directions. Then, my M2A is equal to Fg2 minus tension. So if I solve for tension, my tension now is equal to, right, M2G minus M2A. Now we agreed that this tension and this tension are same tensions, right? So we agreed that these two should equal to each other, right? So let's set them equal to each other and see what brings us here. Here we're going to be M1A plus M1G is equal to, right, is equal to M2G minus M2A. Yes?
What is gravity positive on the mass 2?
Because we established before you came into this class that make the direction of motion to be positive direction. And since 10 kilogram will win going down this way, that is the direction that's going to be positive.
All good.
All right, good. So, let's isolate A, right? Let's bring this to the other side and bring this to the other side. So here, it looks like I have M1A, right, plus M2A is equal to, right, M2G minus M1G. Okay? Now if I factor out A from both terms, right? So my A, here I get simply M1 plus M2. I'm going to go one color now. M1 plus M2 is equal to, I'm going to factor out G here, and I've got M2 minus M1. Okay? So my acceleration is equal to simply G times, right, M2 minus M1 over M1, no, well, same thing, M1 plus M2. Okay? Now let's plug and chug. So if I plug in the numbers, my acceleration is equal to 9.8. Now I'm not putting in negative 9.8, even though it's G, because I already gave direction way up here. Do you understand that? So I am just going to give the magnitudes here because I already made my acceleration's direction positive. So I'm not putting in negative 9.8 in this case. Times m2, which is 10 minus 2 over 2 plus 10. So if you work this out, you should get 6.53 meters per second squared for your acceleration. Now once you have this acceleration, you can plug this acceleration back to these two equations. Any one of them, doesn't matter which one, right? If you plug it into this one, right, you could simply say my tension is equal to, right, 2 times 6.53, right, plus 2 times 9.8. Again, I did not put negative 9.8 in here because I already gave direction up there. So if you solve for tension, your tension is equal to 32.6 newtons. Now if you plug that into here, you'll get the exact same thing. Okay? Now that's one way to solve this problem. Another way would be finding the acceleration of the whole system first. Okay? So if I were to look at this, and if I were to sort of stretch it out and put it horizontally, okay, it's going to look something like this. So here's my M1, right? Here is my FG1, and here's my tension, and here's my other tension. These tensions are the same, we're pointing in this opposite directions. Here's my M2, and here's my FG2. So we're looking at this as a whole one system, just accelerating in that direction. So this will be the positive direction, and this will be the negative direction. So this is negative, positive, negative, positive. So if I were to look at this, sum of all forces total is equal to M total times A of the whole system. Then sum of all force total is equal to, right? I could start from here. I can say FG2 plus tension plus this tension plus FG1. Set them equal to each other. So M total A is equal to FG2, right, plus tension plus tension plus FG1. Now give directions. Alright, so here my mass total times A is equal to FG2 is going to be positive minus tension, so minus tension plus tension minus FG1. Notice how these two added together will just go away, and it works as an internal force. Okay? Therefore, my M total A, which is M1 plus M2 times A, is equal to simply M2 G minus m1g. So if I factor out the g, my acceleration becomes g times m2 minus m1 whole thing over m1 plus m2. Wow! 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 They come out to be exactly the same thing, right? They come out to be exactly the same. So once you plug and chug, you should get still acceleration to be 6.53 meters per second squared. Now, solve for tension. So to do that, right, you need to pick like either this one or this one and either get this equation or pick this one and get this equation. You still have to do this, no matter what. So, I don't know, I like to do it this way, you know. Some people prefer this way. But if you have to just solve for acceleration, I'll just go straight for this. But if you have to solve for both acceleration and tension, maybe I'll probably go for this. That's up to you. Whichever is more convenient. Alright? Any questions? Alright. 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 Let's move to the next page. Page 15. Inclined plane pulley system. Alright? Now this looks like trouble, basically. Okay? So you have two objects that are connected by a light string that passes over a frictionless pulley, as in figure below. Draw a free body diagram, right, for both objects. If the incline is frictionless, so there's no friction here, and if m1 is 2 kilograms and m2 is 6 kilograms, and the theta here is 55 degrees, okay? Find A, acceleration of the object, B, the tension in the string, and C, the speed of each object, right, 2 seconds after being released from rest. All right? Therefore, let's work with the free body diagram first. Now, what is your assumption which way this thing's going to go? Just assumption.
Right?
So this one's going to go down and this one's going to go up. That's a good assumption. But let's find out if that's going to happen that way. All right? I mean, I would assume that as well. All right? Because this is a lot more massive than the other one. All right? So we need to find out. I mean, there's a tug of war happening, basically. Like, you know, one's pulling down, the other one's pulling down, so we want to see which one's going to win. All right? So to do that, we need to compare the forces that's going to be countering each other. All right? If we look at this one, my tension is going to be up, and my FG1 is going to be going down. We don't know which one's positive and which one's negative yet. All right? For this one, we have how many forces? We definitely have FG, FG2, okay? We also have tension. And this tension value and that tension value should be exactly the same because the pulley is massless and frictionless. However, we also have a normal force that's going to be going this way, perpendicular to the surface. This is my F normal. This is my new Y direction. And this is my new X direction. This FG now can be broken up into its components of new X and new Y. Right? This is new X, new Y. So if I break this FG up into its components, okay, here is your FG, FGX, and this here is your FGY. This angle right here is, what is that angle? Louder?
50.
55 degrees?
Is it?
That angle and this angle are congruent angles. We proved it earlier. Nope. We proved it earlier when I showed you right here on page 10 why they are congruent. Therefore, to calculate your FGX, this is the force, FGX, which is the component, horizontal, or no, I'm sorry, the X component of my FG is pulling this along the incline, and FG1 is pulling down this way, and we have to see which one is bigger. Is this one bigger than that? And that's why we have to check to see which way it's going to move. Okay? Therefore, we know FG1 is easy to calculate. So here's my FG1. FG1 is simply what?
9.8 times 2.
Yeah, so M2G, which is 2 times 9.8, which is 19.6 newtons. So that's my FG1. Well, FG2 is 6 kilograms, right, times 9.8. Well, since FGX is the opposite of my angle theta, my FGX is equal to simply FG2 times sine of theta. So my FG2x is equal to, what's 6 times 9.8? 58.8 newtons. So 58.8 newtons times sine of 55 degrees. Right? So I get FG2x is equal to 48.2 newtons. So who's going to win?
Mass 2.
Yeah, so FG2x is definitely bigger than FG1, right? So which way is this going to move?
To the right.
So our assumption was correct, right? So our assumption was correct. So it will move in this direction. That's the direction of motion. Therefore, this is the positive direction for mass 1. And this is the negative direction for mass 1. And this is the positive direction for mass 2. And that is the negative direction for mass 2. Yes?
Could you like make the positive and negative direction like parallel to the one for mass 1, or does it have to be in the same plane as the?
Isn't it gonna be moving along the plane?
Yes.
So we're gonna make that direction positive. So if we were to take a look at part A, right? So for part A, we were looking for acceleration of the object. So sum of all forces for mass 1 is equal to m1a, okay? And then sum of all forces for mass 1 is equal to simply tension plus Fg1. Let's set them equal to each other, and then we'll give directions, okay? So M1A is equal to tension minus Fg1. Therefore, my tension is equal to simply M1A plus M1G. Okay? Now let's take a look at my mass 2. Sum of all forces in mass 2 in a x, because it's going to be moving along the x direction, right? X prime. Okay? We're not going to be worried about the y prime because it's not going to be needed yet. Later on we will need the normal force for friction. However, let's take a look at sum of all force for mass 2 in the x prime direction, and I have two forces, right? Which is simply Fg2x plus tension. So again, my M2A, and this AX prime is same as this A, is equal to Fg2x prime plus tension. Now give directions, okay? Therefore, my M2A is equal to, right? This is basically 48, right? Minus tension. Okay? So my tension, maybe I should not have substituted that in there quickly, is simply, right, Fg2 sine theta minus M2A. Maybe I should have done that. Okay? So now, if we actually set these tensions equal to each other, right, my M1A plus M1G is equal to, right, Fg2 sine theta minus M2A, right? Let's isolate A, okay? So here, my A is equal to M1 plus M2 is equal to, if I bring this to the other side, I have this is simply 48.2 minus 19.6, okay? So my acceleration is equal to, if you do this correctly, what do you get? You get 3.6 meters per second squared. All right, because this is 2 and this is 6. So I can substitute this back into either of this equation, right? So for part, this is part A. So for part B, if I plug it in, my tension is equal to simply M1A plus M1G. So my tension is equal to 2 times 3.6 plus 19.6. So my tension is equal to 26.8 newtons. You'll get the same answer if you plug it into here too. Then, for part C, okay, what is the speed of each object 2 seconds after, right? It's released. So initial speed for both, either one, is 0. Doesn't matter which one we solve for. We're looking for, right, V final when t is equal to 2 seconds. My acceleration is 3.6 meters per second squared. I'm looking for V final. So we can use equation 1 from our summer assignment, which is Vf is equal to Vi plus At. So my Vf is equal to 0 plus 3.6 times 2. So my Vf is equal to 7.2 meters per second. Are we good? Yeah? This is your homework. All right? All right. Shall we do the next page, or you may give you time to work on your homework? Homework. All right, I'll let you work on your homework. All right. So don't waste this time.